In this episode, we look at how data should be handled across its full life, from the moment it is created until the moment it is safely destroyed or permanently removed from use. This topic matters because data risk does not stay in one place. A file can begin as a customer form, move into an application, get copied into a database, appear in reports, travel to a cloud service, end up in backups, and later be exported for analysis or audit. Every movement creates a new chance for exposure, misuse, loss, or compliance trouble. Data handling is the set of rules and practices that guide what should happen at each step. Geofencing, data location, data placement, retention, disposal, and legal requirements all fit into that larger picture. The goal is not just to protect data once. The goal is to protect it consistently for as long as it exists. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Data handling starts with knowing what kind of data you have. You cannot protect data well if you do not know whether it is public, internal, confidential, regulated, personal, financial, operational, or business critical. A harmless public brochure does not need the same controls as payroll records, health information, source code, legal files, or customer identity documents. Classification gives you a starting point for deciding who can access the data, where it can be stored, how it can be transmitted, whether it can be shared, how long it should be kept, and how it should be disposed of. You can think of classification as placing a label on the data's level of sensitivity and importance. That label then drives handling rules. Without classification, people may guess. Some may overprotect ordinary information, which slows work. Others may underprotect sensitive information, which creates real security and compliance risk. The data lifecycle is the full path data follows over time. It usually begins when data is created, collected, received, or generated by a system. From there, data may be stored, used, shared, transformed, backed up, archived, retained, and eventually disposed of. Each stage has different risks. During creation, the organization should avoid collecting more data than it needs. During storage, it should apply access control, encryption, and monitoring based on sensitivity. During use, it should limit exposure to people and systems that have a valid business need. During sharing, it should check whether the destination is approved and whether the recipient has the right to receive it. During retention, it should keep data long enough to meet business and legal needs, but not forever by default. During disposal, it should remove data in a way that prevents practical recovery when recovery is no longer allowed or needed. Data minimization is closely tied to lifecycle thinking because the safest data is often the data you never collected in the first place. If an organization asks for sensitive information without a clear purpose, it creates risk before any attacker shows up. More data means more storage locations, more access decisions, more backup copies, more audit questions, and more impact if something goes wrong. You may hear this idea in privacy and security conversations because it is practical. If a service only needs an email address to send a notice, collecting a full date of birth, home address, and government identification number may be unnecessary. Minimization asks whether the data is needed, whether a less sensitive version would work, and whether the organization can shorten how long it keeps it. This does not mean collecting nothing. It means collecting with purpose, keeping with discipline, and removing data when the purpose has ended. Geofencing is a control concept that uses location boundaries to allow, deny, limit, or monitor activity. In data protection, geofencing can help enforce where data may be accessed, processed, stored, or transferred. For example, an organization may restrict access to an administrative portal so it is available only from certain countries, regions, office networks, or approved locations. A cloud service may be configured so data is stored in a specific region. A mobile application may allow certain functions only when the device is inside an approved geographic area. Geofencing can reduce risk, but it should not be treated as perfect by itself. Location signals can be inaccurate, networks can route traffic in confusing ways, and attackers may try to disguise where they are connecting from. Geofencing is most useful when it supports broader access control, monitoring, legal, and data placement requirements rather than replacing them. Data location and data placement are easy to underestimate because digital information feels like it is simply in the cloud or on the network. In reality, data exists on physical storage somewhere, even when you interact with it through a web application. The location of that storage can matter for law, contract obligations, latency, resilience, audit requirements, and privacy expectations. Data placement is the deliberate decision about where data should live. That may mean choosing a cloud region, a data center, a backup location, a database cluster, or a storage tier. If regulated data must remain in a certain country or region, placing it somewhere else could create compliance problems. If critical operational data is placed far from the systems that need it, performance and recovery may suffer. Security teams care about placement because the location of data affects who can access it, what laws may apply, and what safeguards are required. Retention is the decision about how long data should be kept. Keeping data forever may sound safe because nothing is lost, but it can become dangerous and expensive. Old data may contain sensitive information that no longer serves a real business purpose. It may be stored in formats that are poorly protected. It may appear in forgotten backups, legacy databases, old email boxes, archived reports, or in used file shares. If that data is exposed, the organization may still be responsible for it even though nobody needed it anymore. A retention schedule helps solve this problem by defining how long different categories of data should be kept and what should happen when the period ends. Some records must be kept for legal, financial, contractual, or operational reasons. Other records should be deleted sooner. Good retention balances usefulness, legal duty, privacy, storage cost, and security exposure. Legal and regulatory requirements can strongly affect data handling. Some data must be retained for a defined period. Some data must be deleted when it is no longer needed. Some data may need to stay in a particular jurisdiction. Some data may require special protection, notice, consent, logging, or breach reporting. Personally identifiable information, PII, protected health information, PHI, payment data, government data, student records, employee records, and legal records may all have different handling expectations depending on the organization and environment. You do not need to memorize every law to understand the security plus idea. The key is recognizing that data handling is not only a technical choice. It is also shaped by legal, contractual, privacy, and compliance obligations. Security teams need to work with legal, privacy, records management, and business leaders so handling rules match the organization's actual responsibilities. A legal hold is an example of why disposal is not always as simple as deleting data when the retention period ends. If data may be needed for litigation, investigation, audit, or a formal dispute, the organization may be required to preserve it even if it would normally be deleted. That hold must be communicated and enforced so people do not accidentally destroy relevant information. This can affect email, documents, chat records, database entries, backups, system logs, and other records. Legal holds show why lifecycle management needs coordination. One team might see old data and want to delete it to reduce risk, while another team may need to preserve it because of a legal duty. The correct answer depends on context. Mature organizations document these decisions, assign responsibility, and make sure disposal routines do not override preservation requirements when a valid hold is in place. Disposal is the controlled removal of data when it no longer needs to be retained. For paper records, disposal may mean shredding, pulping, or secure destruction. For digital records, disposal may involve secure deletion, cryptographic erasure, media sanitization, degaussing, or physical destruction of storage devices. The right method depends on the sensitivity of the data, the type of media, and whether the device will be reused, returned, sold, recycled, or destroyed. Simply deleting a file or emptying a recycle bin may only remove a pointer to the data, while the actual content may still be recoverable for a time. Disposal also needs to include copies. A record may disappear from the main application but remain in backups, exports, logs, caches, reports, or test datasets. Good disposal planning asks where all copies might exist and how each copy will be handled according to policy. Backups and archives make lifecycle management harder because they preserve data beyond the primary system. Backups are usually designed for recovery, while archives are often designed for long-term reference, legal records, or historical retention. Both can contain sensitive data. If an organization deletes a customer record from the active system but keeps years of backup copies without a plan, that data may continue to exist far longer than expected. At the same time, backups may need to remain intact to support recovery after ransomware, corruption, accidental deletion, or disaster. This creates a careful balance between availability, retention, privacy, and disposal. Some organizations use backup expiration rules, archive retention rules, encryption, access restrictions, and documented restoration procedures to manage that balance. The important point is that data lifecycle decisions must include secondary storage. Data does not stop being sensitive just because it moved into a backup or archive. Data handling also includes daily use and sharing. A well-protected database can still lead to exposure if someone exports sensitive records to a spreadsheet, sends them through personal email, uploads them to an unapproved file-sharing site, or copies them into a presentation. This is why handling rules need to be understandable to the people doing the work. They should know when data can be emailed, when encryption is required, when sharing needs approval, when masking or de-identification should be used, and when a lower sensitivity version of the data is better. Technical controls can help by restricting downloads, warning about sensitive content, logging access, or blocking certain transfers. Still, the human part matters. People need clear expectations that match real workflows. If the rules are vague or impossible to follow, users may create workarounds, and those workarounds can become the actual risk. Compliance depends on evidence, not just good intentions. An organization may say it has retention rules, disposal rules, access restrictions, and geographic controls, but it may still need to prove those controls are working. Evidence might include data inventories, classification records, retention schedules, access reviews, audit logs, vendor agreements, disposal certificates, encryption settings, backup policies, and approval records. This is where data governance and security operations connect. Governance defines how data should be managed. Operations carry out the controls. Compliance checks whether the organization can demonstrate that the controls exist and are followed. You should not think of compliance as paperwork separate from security. When done well, compliance creates traceability. It helps answer where data is, who can access it, why it is kept, when it should be deleted, and what happened if something went wrong. For Security Plus scenarios, look for the problem being described before choosing the control. If the question focuses on where data is allowed to reside or be accessed, think about geofencing, data location, and data placement. If it focuses on how long records should be kept, think retention. If it focuses on removing data after it is no longer needed, think disposal. If it mentions litigation or investigation, think preservation and legal hold before deletion. If it describes data moving from creation through storage, use, archiving, and destruction, think lifecycle management. If it mentions laws, privacy, contracts, or required proof, think compliance. The exam may use similar words in close proximity, but the scenario usually gives you a clue. Your job is to connect that clue to the purpose of the control instead of picking the most technical-sounding option. The larger lesson is that data protection is a long-term responsibility, not a one-time setting. Data is created for a purpose, placed somewhere, used by people and systems, copied into other locations, retained for a period, and eventually disposed of or preserved for a valid reason. Each stage needs rules that match the data's sensitivity, business value, and legal requirements. Geofencing can help control location-based access or placement. Retention schedules keep data from being kept forever without reason. Disposal reduces exposure when data is no longer needed. Compliance provides the proof that handling rules are more than promises. When lifecycle management works well, the organization has fewer forgotten copies, fewer unnecessary exposures, clearer accountability, and better answers when auditors, customers, regulators, or leaders ask what happened to the data. That is the practical security value behind this entire topic.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.